Substitution with definite integrals. I'm going to show how to do this two different ways, the long way and then the faster way but it actually doesn't matter which way you choose. It's your choice, okay? So if you're going to evaluate this, the first thing you're going to do is pick a value of u. What's u going to be? X squared plus 1. So du is equal to 2x dx. Therefore, du over 2 is equal to x dx. So that gives us that, and that is all gone. So the integral is now u cubed du over 2. Everybody follow that part? Sorry. That's just the stuff we've been doing. Okay? Now you find the antiderivative of that, which is what? U to the 4 over 4, but there's a 2 there, so I'll put an 8. And then you would plug back in what u was. And because it's a definite integral, you evaluate it from 0 to 1. What do you put in first? 1. So I get 1 plus 1 is 2, so it's 2 to the 4 over 8 minus 0. 0 goes in, you get 1 over 8. What's 2 to the 4? 16? So I get 16 over 8 minus 1 over 8, which is 15 over 8. Okay? And there's your answer. So what we did is we used u sub to get the antiderivative, u to the 4 over 8, put back in what u was, right? And then evaluated it between 0 and 1. And got our number. Perfectly legitimate. There's a way you can bypass some of that. If you look at this point right here, this I've written it as an indefinite integral, right? It's got no upper and lower bounds. I can write upper and lower bounds for that. It is not these though. These are x values, okay? But what do we know? We know that when x is equal to 0, what does u equal? 1. Because if I put 0 into here, I get 0 squared plus 1 is 1. So when x is 0, u is 1. And when x is 1, u is equal to 2. Those are my bounds in terms of u. So now this integral, if I want to, I can write from 1 to 2. Whoops. Which means when I find the antiderivative, I can now evaluate this between 1 and 2. And then just go 2 to the 4 over 8 minus 1 over 8, which is 16 over 8 minus 1 over 8, which gives you the same answer. So you're saving yourself. Now, this isn't even a complicated integral, right? And putting the x squared plus 1 back in is not that hard, right? It doesn't make a ton of difference. But you can imagine, I'll scroll back to this in a sec. The one we did at the beginning of class, like this one, if I was going to sub back in, I feel like this would be a lot easier to deal with than this, okay? So as the integrals get bigger, you can always just put it back into your x's and do it if you want to, but it saves you a bit of work and a bit of possible error, okay? So you just have to remember that the bounds will change into u values, and you use what your substitution for u was. All right, we're gonna do one more, and then I'll let you do some practice. This one will be a little trickier, I think. Integral from 1 to 5 of x over root 2x minus 1. All right, first move. Sorry? Rewrite?
Yeah, like x times 2x minus 1.
But that's not going to help you, though. You could do that, but that's not going to help you. You're going to have to do some sort of U substitution. What do you want U to be? 2x minus 1. Okay, so du is going to be 2 dx. Okay. So we got rid of this bit is u. This bit is du over 2. We still have the x. What do I do? Yeah. So I'm going to use u is equal to 2x minus 1 to solve for x. So u plus 1 divided by 2 is equal to x. There's our last substitution. So it looks like that. But also we can change the bounds, right? So what are the bounds going to become? When x equals 5, what does u equal? 9. And then when x is equal to 1, u is equal to 1. So now the bounds are from 1 to 9 of du. And now we never have to look back at our x's and sub that out. We can just deal with this integral. Which doesn't look that friendly right now, but it will in a sec. All right. What are we going to do? So 1/4 could come out. Is that what you mean? Like this and this. That's a quarter, right? Okay, well, we won't move that. Hang on. So what we're going to do is clean this up. So that's over 1. So you can flip the denominator. You'll get the integral from 1 to 9. So we get that. Right? Flip and multiply. And then do, yeah. What can you pull out? 1 over 4, right? 2 times 2 is 4. So 1/4 can come out. And I have u plus 1 over u to the 1/2 du. What do we do now? Can't do the antiderivative, sorry? Split them up. If you have a single denominator, split it to both. What's u over u to the half? That's just u to the 1/2. I'm going to flip that one up. Now I'm ready to do the antiderivative. Okay? So everything else is just a setup. We haven't even done any calculus yet. Right? Now we're ready to do calculus. The calculus is like one step. Right? And then it's all back to algebra. So, what's the antiderivative of u to the 1/2? 3/2, and then 2/3 in front, right? Plus, add 1 to -1/2, and you get, divide by 1/2, you just throw a 2 in front. And we're evaluating it from 1 to 9. So calculate, everything was a setup to there. This one step is calculus, and then we're back to algebra. So we put in the 9. And I'm showing every step. If you can skip a few steps in your head, that's fine. So that looks gross. It's not that bad, though. These are all usually made to work out pretty nicely. Ooh. All right, everybody? Oh, wait, so everybody copies it down. Okay, we good? No? Okay. What does a power of a half mean? Square root, right? What's the square root of 9?
3.
What's 3 to the power of 3? 27 divided by 3 times 2.
18.
There you go. It's in the video. Plus 9 to the power of a half
3.
times 2. And if you have ones, that's just 1. Super easy. So I get 2 over 3 minus 2. 18 and 6.
13.
What? 24?
Adding.
How do you get 30 multiplying?
I got 30. I said 30.
Oh,
No,
30. Oh,
30.
you're oh, I see. Okay.
Yeah.
How do you get 13?
Because I saw that as a minus for some reason.
What's 18 minus 6 though?
18 minus 6 isn't it 13?
It's 12.
Oh,
So 18 and 6 is 24. Negative makes that 2 positive, which makes it 26 minus 2/3. That's not going to be fun.
25
okay. Okay, what if we fail in the...
What if you fail in this part? This is a grade 9 math problem.
I know.
You will lose a mark if you do everything right, but you mess this up.
Okay, but we got most of them.
Yeah, you'll get most of them. Okay, 26. So let's make a. What do we want to do here? Let's do. Is it 26? 18 and 6 is 24. You're right. Why is it -2? That's supposed to be a positive 2. So then that's 22, right? I was just checking to make sure you were doing it right. I was illustrating the mistakes that you can make for the benefit of your education. Thank you. 22 minus 2/3 divided by 4. 16 over 3. Okay? Or the equivalent decimal. If you give me the decimal, I'm fine with that. Okay, so quick summary. When you're doing it, if you're going to change the bounds, you have to use whatever you did for U substitution, and then they follow all the way through. If you're not going to change the bounds, be careful that you don't plug these values, your original x values, into this. Okay? You have to put back in what your u was, in this case x squared plus 1, before you use the x's. But if you change the bounds, you can just use u's all the way through and you get the same answer. Okay? Page 302, 55 to 61, odd 65 and 67, please. That'll be enough for today. Tomorrow we'll do numerical integration.